Okay, so welcome all. So next up we have Mattias Lögdberg. So from earlier conferences, we know that his sessions are always engaging without using many slides. So let's see if he follows up on this habit. So in this session, Mattias speaks about Service Bus and Event Grid, their differences, strengths, weaknesses, and more. So the floor is all yours, Mattias.
Thank you very much. And I will not disappoint you. I have a opening slide, and I have, let's see. I have a slide on my title, which is not much. And I also have a short agenda. What we will do, I will bring in some backgrounds. We have seen some awesome demos, patterns, scenarios, and stuffs over the days, which means that you will have a good background on things that's going on. But even though I want to go back in a little bit deeper, we will also talk a little bit about PubSub and what that is, and we will also have some streams. But in the end, let's start with the one thing I love. Let's do the whiteboard. So. At this conference, we have seen a lot of messaging. We have seen a lot of patterns, I would say, rather, not messaging. We have seen a lot of patterns. We have been told about what's happening in the space. If you saw Clemens and Kevin's show, you have seen all what's coming up next. What I'm going to do is actually bring things down a little bit to the depths, because when we come up into the cloud, I feel that we kind of forget a little bit about the messaging space. And the messaging space is often just told in patterns and stuff like that. So I will bring this down a little bit in the end, why we need patterns or why we need messages. Patterns is definitely needed. So messaging in the end is very simple. So messaging is someone is sending something via a queue to someone else. And the queue is building up, making it possible for the consumer B to be off grid for some time, meaning that A doesn't know that B exists. And this is a very vital pattern. So let's just look into something that I think we are doing today, and why we kind of forget a little bit about this queuing stuff. I have put up let's begin. Sorry, I will draw that first. Hang on, my whiteboard just lost me. Not nice. Let's just remove this one. So I'm just going to talk about this common scenario. So we are today building a lot of APIs. And behind those, we are using things like functions. And we have some sort of data source behind this. In the end, we are publishing messages to this, and in the end, something is going down to the system. So in my case today, what I want to show you is that we have a publisher who's going all this and actually pumping this function and going to a system behind. And everything is done via HTTP. And let's just look into how this looks like. So we have a function, and I will use Postman and post data to this one. So let's just go ahead and do that. So I will just send a message to my service. So I'm just going to show you that this is going to work. So I get back my customer, I get this text back, which means that I actually created something in my system. So this is good. But let's move to a production site where we have some volumes instead and see what's going on. So I'm going to actually go ahead and fire off some PowerShell scripts. And let's see. Execute Postman, that's right. So now I'm firing off the same thing I did right now, but just in a more, oh crap, I need to do something first. I want to go to my application insights. So we're going to see what's happening when we're pumping the volumes into this HTTP endpoint. So let's bring into live metrics. So we can see that we're pumping quite a lot of messages in this one. We should see the screen coming up quite shortly. So everything looks fine. We can pump this and we can insert these messages. Behind the scene, I'm using a Postman. I'm using Cosmos with a low rate, which means that when we start pumping a little bit more, we will get to the limit of that cosmos, which is fun. So let's just go ahead. So we can see that in serverless, we spin up a lot of more servers, and we can see that request rates is going up the roof. So when we come into serverless space, we often get these benefits that we have this, it just scales. But in this case, we start getting errors. You can see the dependency call fail rate, which means that my dependency, my backend, in this case, the Cosmos, has a too low, call it, it says too low settings. I think it's only have 400, and which will mean that in the end, we will end up with a lot of failures. And this actually is a lot of requests going into this. And we also have a bunch of stuff going on. So now we can see that having this endpoint like this is quite vulnerable. So if we get something poking on, we could obviously solve this with a bunch of things like rate limits and others. But this is also applicable for service windows or whatever we have in this. So if we go to failures, I'm just going to show you also what's going on behind the scenes. So if we just go in and see for one of these messages, we will also see that due to the fact that we have quite a bunch of, maybe not. Okay, let's go back a bit. Hasn't been loaded. So due to the fact that we actually have a lot of SDKs helping us out, we actually have a bunch of help doing this. So we have a bunch of retries. So behind the scenes, every message that comes in to my function in this case. So this is a very small function. Let's just show me that one. Let's just go. So these functions only consist of these rows. So when we come in, we read the result, we just create a data object, and then that's an output to the dynamic object that goes to Cosmos and via the function runtime. And afterwards, we just return a great result or a bad request. But we have this. So we're letting the engine beneath do this, which means that we have an SDK, which helps us out and do a lot of retries. And this might be quite, you can say that this is neglectable or this is really good or whatever you want to use. But what we need to remember is that there's a lot of messaging going on. And if we have, depending on what services we have in front of this, we get retry storms that can be huge. So let's just say that in our drawing, let's say that it wasn't Postman that actually ended the call. Let's just put in a standard logic app, for instance. We have by default, if I'm not mistaken, 4 retries until it goes down, which means that as soon as we start getting retries, it's going to go ahead and wait amount of time, and then it's going to retry again. So the spike that we kind of introduced right now is going to go ahead and become again and again until eventually dies if we haven't put up the system or if we haven't scaled up Cosmos on time in this case. And these burst loads are, we may have a top like this. Let's just say that this is the top of our Cosmos. If we go over this, we start getting 429s. We need to be able to build something that actually can go ahead and scale like this and start pumping messages like this instead over a longer period of time. So in order to do this, I have also did a, in order to do this, we can use queues, for instance. So as mentioned before, queues are very simple. Queues are something that goes on. We have a sender, we have a queue, for instance, and we have a receiver. In Azure, we have a few options. We have storage, who have queues, and we have service bus. If we're going to talk about queues, we have those 2 as options. So let's just demo storage, for instance. So let's just jump into our storage. And let's go ahead and jump into that storage over here. So in a storage account, we got something called queues. can find over here. I don't have any queues yet, but let's just go ahead and start I got a publisher. So I've prepared a publisher. This is just a simple, no, this was service bus, sorry. We'll have send message to storage queue. So I have a small console application that I will fire up. This one is just creating up a connection and creating a queue if not existing. And I can then start sending messages. So let's see, that's starting up. And we will have a queue and we can just send test. Integrate 2021 rocks. And hello world. Here we go, we can send messages. Let's go back to our storage account and let's just go refresh. We can see that we got this new queue over here, which I created on the fly. We can also see that I have these messages. So a big difference between the function that just processed and sent right away is that this is stored and being later used, which means that I can then, at any time I want to, I can actually go ahead and create a listener. So this is a listener connecting to that queue and gonna go ahead and just read those messages. And let's see, starting up, and then you can see, and just for show, I can just say, hello live, and it goes live. So this is a simple way of doing this. So this is simple queues. And I want to use this mechanism because if I can use this part, I can make sure that my Cosmos can stay at the same cost and same rate without being plugged from these senders, which means I want to use something else. So I've created a small messages to service bus. So this is actually very, very similar to my other one. So if I have Cosmos API, let's just remove, and let's just move that one and remove that one. It's very similar. I'm using the inbound stuff, inbound triggers in functions and using the HTTP triggers. The difference is actually that I have service bus in this case and I have Cosmos DB in this case as outbound from my function. Everything else is the same. So this is using bindings in a simple way. I can just switch that to service bus, and then I have the same API being pushed up, but it's going to the service bus instead. So then I have my Cosmos. So if I'm going to go ahead and just show that from this point of view, I still have the same message. I just press send. The message will now go. From my postman to my function to service bus. And it will stay there until my other function over here will take that message and populate that to my Cosmos. So in this case, I can then just put in this. I've added one more function and I've added service bus, but I will increase the reliability on my API with so much. So if I'm going to do the same, I'm going to go ahead and do these scripts again, but I'm going to go ahead and use Postman to service bus. Oh, let me switch that, by the way, end-to-end transaction to API service bus. And let's do the live metrics. And let's go ahead and just fire off this one as well, service bus. And we take this one. Here we go. We can see that the request rate is all again firing off the roof, and we can see that the service is spinning up. But in this particular case, we will be okay with request failures because we don't have that dependency to something that is weak on receiving things, because now we have the service bus instead, which has a more higher receive rate than Cosmos has in my case. This is as again with the it's RU, so I've only configured my Cosmos with 400 RUs to simulate this kind of behavior. So you all know why Cosmos not receiving that. So this is a way of making sure that I can pump all these messages and making sure that they are ending up in Cosmos. It takes a longer time, obviously, but it will again, it will be there anyway. So it takes a little bit difference when designing messages, because if you look at the responses, you will not have a unique ID going back, for instance, but you might want to have an order number or an external reference ID that you can use instead to do that, and exposing that to an API or something instead, making this whole flow async. As mentioned, I think this is often forgotten in today's SDK world. Well, we have so much retries and so much help going on in this case, so we usually don't end up in this until we get in high volumes. So let's continue that story, and let's just talk a little bit more about Service Bus. Let's go into Service Bus, and we have something called Service Bus Explorer. There we go. So this is Service Bus. In Explorer, I can see that we have queues and we have topics. We have created something called pub/sub, and we have subscriptions. I have 3 subscriptions in this case, and each of this is, when I talk about topics, it's how we can pub/sub. We can then publish and subscribe. So if, say, for instance, we have a publisher that needs to send something to many parties. So we have a bunch of parties over here. We need to then we can then use this topic in Service Bus and then create subscriptions. There we go. And then everybody can get this. We can even add filters. So we can add filters over here, making sure that maybe we just want some files. And the publisher is still publishing the same message, but it could publish a few properties on the header level. And based on that, we can actually create a filter. So in my case, we can create, let's say that we have a sender field and we have a ERP, for instance, flag. We can say that we can go ahead or we can use something called message. We can even use something like customer. We can even have that customer is customer A, which means that we can just filter out those. So A and B and C can get their own messages, or maybe this one just want to have all of them. Then they can get all of the messages. So Service Bus Topics is a great way of adding this to it. If we go into the portal, we can go ahead and jump into topics over here. Oh, not Cosmos, sorry. I want to have my Service Bus. There we go. So in this one, we have queues and topics, and we can see that we have queues and topics. You can also see that I pumped quite a lot of messages quite recently. And we can see, as we saw in the Service Bus Explorer, we can see the queues and we can see the topics. And we can also see what subscribers we have, and we can see everything in there. I'm going to use this Service Bus Explorer a little bit because it's easier to show off. Because if you see this, I hope you can see at least these 3 subscriptions over here, A, B, and C. We can then actually see how this looks like when we do a publish. So if I'm going to go ahead and do a send message on this topic, and I'm just going to send hey man, how are you? And just send. We can then see on the subscription side over here, easy in this case, that we've got an extra message on A and B, but not on C. So I think I have some of the rules over here. So this is the rules. We got sender called ERP. Okay, so sender ERP. Let's just go ahead and add that property. So this is the message properties. I can just add ERP. And let's send again. So there we go. We got this on system C as well. So we got a message over here, and we can actually read the message. And we can see, hi mate, how are you? We can actually do the same in the portal nowadays. So we got Server Bus Explorer Preview, which is really good for inspecting your messages. So let's just go ahead and take a peek. And let's pick System C again. Let's pick that one. Because here we have one message. This is the message, and we can see it again. Hi mate, how are you? We can also see that properties that we set up on this. And we have some other properties as well. There's quite a lot of settings on this that we can do regards of messaging and stuff. But remember that messaging size is limited on Service Bus standard to 256 kilobytes, and in premium 1 megabyte for now. Migrating to premium you can do very easy over here. Remember, you can't migrate back. So if you do that, you're one-way ticket. We can also work with encryptions and stuff like that. Bring your own key, for instance, if you want to make sure your messages are encrypted. So that's good. Now I have been quite rapidly gone through the storage, and we have gone through some functions, and we have done some messaging, and we talked about PubSub. So we have talked about storage queues, and Service Bus. We have talked about queues. So queues are really good for one-to-one. So 1-to-1, sending a message to someone who wants to have it, and also making sure that you can target peak. You can make sure that peaks are not messing up your downstream systems, and you can also have this downtime. So it's also very good if you have like maintenance windows for the receiver, making sure that they can be online all the time, or making sure that your APIs or whatever suits the sender can send it anytime they want, and the receiver just come up and down when they are available, and the message is stored until that. We got topics, which is one too many. A good idea here is to think of a publisher as they don't really want something, they just want to send out this message. And anyone who wants it, I mean, if we have all of these A, B, and C, they are responsible for managing it, also responsible for this subscription. So if they want to have a filter, it's up to them. The publisher will always publish and just put up a bunch of properties to make sure that the sender can filter out whatever they don't want to listen to. A very simple way of making sure that you can send away messages to many people. So when it comes to this, we also have, next up, when we talk about PubSub, we have Event Grid. So Event Grid is in many ways different from Service Bus. I think the main thing is that they have this one too many. So while Event Grid is a push, I think it was forwarding. I think they used the word of it, push forward. So when I want to send something out, it makes sure, so Event Grid will then make sure that it will be sent to all of these parties. So let's just use A, B, and C again. Big difference here is, as mentioned before, that this is sent forward. So this is actually pushed forward. So when I do this, it will be sent. Not as the Service Bus that will push them on the queue until you are ready, and then you can start dequeuing. So they will really fire away right away. So let's just look into Event Grid, and let's go ahead and look at that. So Event Grid, we have over here. So it's very similar to the setup where they have event subscription. So they have event subscription that is there. You can see that I have 2 subscribers, Event Grid Viewer and Event Grid Broken, which we'll come to a little bit later. But Event Grid Viewer is actually a site. So let's just go ahead and look into how that's looking. Might have been encountering similar stuff. during the day, during the week, I would say, because this is still an event grid viewer. So while that's jumping up, let's just move into Postman again. So I will then use Postman to be the publisher events. It's a little bit more information in this. There have been talks about this earlier about the different types of messages you can send in. I'm just using standard cloud. And I'm just sending in basic things like an ID and message event type and subject, and also a core data blob object, which will be more or less the data I want to send. It has also been a lot of discussions before around what to send and what to not send over Event Grid and Service Bus, so I won't go any further in that. I will just focus on the mechanism over here. So this is what I want to send, and I got my Event Grid viewer Blazor up and running. Had to use something else than the other ones we're using. So let's just send something out. So we can see I got this message, and it's all the same, nothing strange, everything is good. So this is nice, very simple, very fast. And as mentioned, this big difference between this part and my earlier part where I had the service bus is that nothing is queued. This is, if I wouldn't have a subscriber, nothing would end up here. So if I'm opening up another one over here. Let's just go ahead and add one more. Let's add a subscriber, event subscription. So I have, oh crap. Come on. Okay. Let's do like that. Let's just open that bit because that one will take some time. So I have another one. It's almost the same, but let's just see what we can do when we add a subscription. So this is creating an event subscription, and I will have this event with viewer, and it will be called filtered. We will try some filtering stuff. So it's a topic, it's a resource, that's good. I have an event, an endpoint, I have a webhook. Select that endpoint. There, go. We can then go to filters. So I can go ahead and add a filter. And I would say that often I do subject filtering, but let's just go ahead and do something add. So let's just filter on the custom data. And I will then have data. Oh, let's go ahead and look at my data, by the way. Sorry for not being able to zoom into my Postman, but there's a data and there's something called partition key. So let's just go ahead and steal that. So data dot partition key. And let's just go ahead and set begins with. And add a new value, and let's just say customer. How do I have a good one? Customer A is that, so let's just add customer B. Customer B. Sounds good. Small or big one? Okay, I need to change that. Sorry, customer B. We can also go ahead and put on something called dead lettering. This will actually make sure that so Event Grid will try to deliver your messages, and it will have an exponential time off every time it fails. So first time it's right away, and then it's 10 minutes, and then it's something else, and then in the end it's hours. And when it comes over the limit, it will actually do some dead lettering. So then we can enable that and store those messages in a blob storage. We can also decide the retry policies, and we can see that this is 10 attempts, 2 hours, and yeah. Let's just do that. We can also add some custom properties to the delivery as well, but we don't use that now, and this Event Grid viewer won't see it as well. So now we have added that. So let's just go ahead and publish some more events. Let's just clear this one out. So we clear this one out, and I will add this up. We can see that one pops up, and we don't get anything here. So again, we send this one, we don't get anything. So if I go back and I just put a B over here, we can see that this message ends up over here. And we can see we have now 3 messages. So in the first one, everything pops up, and the second one is 2. So this is how we can do adding a subscription to our event grid, and we can see that. Messages in event grid should be really small, so they should be about 64 kilobytes, but still it's a good way. So in short comparison between these two, so let's just go ahead and say we have topic and we have event grid. So in topic, we actually have under the hood, we have queues, which means that when we send something, we will add it to the queue. So every time you send something, it will end up over here, a new message going into that queue. And whenever a subscriber, because this is the subscription, so every subscription actually has something, it's type of queue, more or less. I wouldn't maybe not say queue, but still something like that. Then the sender can actually go in and say, hey, I'm ready now, just bring me my messages, and they will pop out. And then you will dequeue them all the time. And that goes for each subscriber. They can do that. Event grid is then, as we saw right now, it's getting a message, and then it's just a forwarder. It will, as mentioned before, it will retry and will do that over time until it has been delivered. But there's a huge difference in timing for this because event grid won't just say, come and get it when you want. They just want to send it. So if you miss one of these and you get into a window, you can have to wait until event grid is ready to resubmit the message, not so as a topic where you can actually go in and pull it off. So that's one big thing. Then we have been talking about this messages event. Okay, so messages and event, commandos and stuff like that. I won't go any deep on that, but that's also something that is different. The messaging size is 64 kilobytes and it's 256 kilobytes or a megabyte on the service bus side on the topic, which is a huge difference. Yeah, but even though from cloud perspective, I really like event grid because event grid gives me the benefit of actually moving things forward in a good way, in a simple way, in a fast way, as long as my messages is quite small. But it's also a bit of difference when it comes to acknowledgement and stuff like that. So need to make sure of that. So for instance, let's just say use event grid with logic apps, and you actually get, if you fail the logic app, event grid won't retry it, but you will have a failed run in logic app. If you go to function and you fail the function, and then event grid actually will go ahead and resubmit that message sometime later on. So it's good to understand how these triggers or bindings are working for you in order to do this. So let's just take a look about this dead lettering stuff that we are talking about. So let's just go ahead and, because dead lettering is, let's just talk about dead lettering, by the way. Dead lettering, I think it's important to understand the difference, because if you as a sender, in Service Bus, you can say how many deliveries you want. You can say that per queue, I can say 10 retries, for instance. You can say that in event grid as well, 10 retries. But the retries mechanism is quite different, because in Service Bus, you are in control. And when these 10 retries are done, you can dead letter it. So then you will have this on a specific place, and you can go in and look at it, and you can go ahead. In this case, and you are in control. So you have the consumer controls errors and when to do things. In this one, we still have even 10 retries, I think. And then you have the event grid controls retries. And then it can come up to that letter if you add that. The big difference here is that you, from a developer perspective, need to understand that when you are dealing with it. So let's just really quick just go in and have a service bus broken. I just need to add a subscriber to my topic we were using last time. There we go. And let's just add that one, create a subscription. Broken, sounds good. And I can have this max delivery count set to 10. And if I go back to this one, and I will just start debugging. So let's just send this message once again. And since I didn't add any filters and so forth, it will just go ahead. My super good function will then pick it up, and you will see my awesome message. I'm Mate, how are you? And I have a throw new exception error over here, which is really bad. But anyway, so this will just spin off, and I will end up having that dead letter. So my broken have one message right now. Let's go ahead and refresh. And now it has one on dead letter. So that's the second digit over there. If I'm going to my dead letter queue, I can go ahead and peek it. And I can see that my message over here. So this went pretty fast. Actually, if I would do the same for event grid over let's see my broken event grid subscriber. There we go. So I have the same subscribers, just reading the data and then just throwing in an exception. This I actually started yesterday, so we will see if it's done, if we are ready. So let's just go into that and see how things are going. So if I go to switch to errors, you can see that I started getting errors over here back in that day. And then you can see I got retries going on quite frequently. And still I have over here, still have retries. Now I've bunched in some new ones, and then we get some new ones. But these are still on the bounce. Let's just see if they ended up, because I have configured that this should end up on my storage account. So I have my storage account. There we go. And I have a container for dead letter. There we go. Still no messages. So still, I haven't got these dead letters from Event Grid, and I started this over 24 hours ago. But I had it on my service bus right away. It's also good to know because you need to be a little bit more aware of what's going on in your event grid rather than on service bus, which is more of just making sure your dead letter queue is safe. It's a good one to know. So that's a little bit about that. And let's just bring in the last piece in this discussion just to make it complete. Let's bring in Event Hub. Event Hub is
Sorry for the interruption, Mattias. So I just want to remind that we have 5 more minutes before the session scheduled to end.
Perfect. Sounds good. Thank you very much. So in the Event Hub is working more of an event stream. So it's a stream. So you're building a log. So every time you are adding something, so when you send something in, you will start building. Every consumer of the Event Hub can then go in and read. So they have a pointer, so a pointer in time, which then will move over here. Big difference between this and all other techniques we have been talking about right now is that you can actually start reading again at different points. So if, for instance, you get an error over here and you want to understand why that error occurred, you can actually go in and start reading back over here again and redo the work again. A big difference. Event Hubs is, I think it's standard is 24 hours keeping data, and then it's just removing the old data. So you need to keep track of that and don't have too much downtime. But it's a difference between this, and also Event Hub is really good at digesting data. So if you have huge amounts of data going in, Event Hub is really good to get that in without having issues on the performance. But I think I'll I'll stop there and see if we have any questions, since it's less than 5 minutes left. So let's see. There we go. Let's see. Let's start from top. So when do you choose between queues and topics? I would say that queues versus topics is quite a simple one. Queues is one-to-one and topic is one-to-many. It's not entirely true, actually, because you can do quite some fun things on queues and topics on the service bus. You can actually connect them together. So even if you pick a queue in the first place, you can connect it to a topic, which is really cool. So let's just do a short thing on that. So we can actually go ahead and say that my messages over here is going to forward to a queue. So I can actually go ahead and say that messages is going to be sent to my topic, which means that I can pick this topic, and any message I will send to this one now. So send my message again, start, will then end up to my topic. If it was sent okay. Yep, there we go. So every time you send a message now, it will end up on a topic, which means that even if you pick that one, you can do that. But you can think of the queues as one-to-one and topics to one-to-many. So a real world case when you needed your storage account queue instead of service bus queue. I would say that the reliability of the storage account queues is really good as well. If you're not aware, if I'm not mistaken, the durable functions is built on top of storage account queues, so they're using it heavily. But I would say that it could be performance-wise, or when you need to go ahead and do more complex things, because storage account is just a queue. You can do much more in the service bus space. So I don't have I would say we have used it when we are doing small queue stuffs, which we always know is just storing up for batching. That's the time I'm using it. What happens if the service bus queue reaches its messaging holding limits? Yeah, well, that's not so much fun. I haven't been encountering that actually in production yet, but I would say you get errors. I haven't tried, but I would say that you get errors from service bus when trying to push new ones. I think it's a difference between queue and topics as well, because subscription is you still can publish on topics even if one subscription is on max. Even if you want to have multiple subscribers to read the same message, you would use topic, otherwise queues. Yes, exactly. If I want multiple subscribers to read the same message, I must use topic. Queues is a one-to-one, and you can only read the message one time in a reliable way. Is there any limit of subscribers you can have on a specific event for event grids? I don't think it's a limit. I don't know, actually. There might be a limit, but I think most limits we are encountering is subscriptions more on a specific event grid. I think it was 25 in the past. I'm not sure if they have increased that, though. It's also 25 when it comes to filters. How can we add subscriptions for service bus queue, which is in a different Azure subscription in the portal and ARM templates? Oh yeah, you can actually do quite easy when it comes to subscriptions, because subscriptions is based on, let's just show you. So you will have this shared account key. So let's just go into service bus. No, service bus. So it's shared access policies. You shouldn't use the root man and shared access keys, but for demo purposes, I use that. So you can use this primary connection string or secondary connection, but this connection string will give you access to this, even if it's another subscription, even if it's some other provider is doing that, a customer or partner, for instance. So you can do that. You can do that via, I think you can do that logic apps, and you can definitely do it with functions, because in functions, that's exactly what you're doing. So if we go to my broken over here and we see the settings, you put in the service bus connection string over here. So this is how you connect. So it has nothing to do with what subscription I'm in. How to deal with big messages, like 200 megabytes. Yeah, you have to do this claim check patterns. If you checked Derek's session before, go ahead and do that, because you would have to use something like claim check patterns, and you can use that over Service Bus, or you can actually do it over Event Grid if you want to as well. But none of these will handle that size of messages. Know that Clemens talked about they're going to release 100 megabytes on Service Bus, but still 200 megabyte needs to store it somewhere in like a blob storage before, and then use claim check. Can we retry messages based on same key? If specific errors, should retry others not? Not sure if you're referring to Event Grid or if you're referring to Service Bus, but you can have a retry mechanism. If you're building your consumer, you have more control. If you have Event Grid, you have to, Event Grid will retry until it's done. Can you define the time between retries and Event Grid? Yes, you can. It was that played, I think, when we created Event Grid. So you have subscriptions part. See. Configure retry, so you can access specific event time to live and max delivery attempts. So mine is too long, my time to live. You can also go ahead and actually do something. I forgot about this one before, but I can take it now since we're talking about. You can actually add a lot of endpoints in this subscription. So you can add storage queues, or you can actually add Service Bus queues or Service Bus topics, which means that you can connect this overlapping messaging as well. Just as I did with the Service Bus queue pointing to a topic, you can also use this one to point to a queue. And in that case, make sure that if there's a subscriber who's not that reliable or not able to handle the pressure, you can just push them to a queue instead. We currently run RabbitMQ. If you want to move to Azure in local Kubernetes, logic apps are fine, but what about messaging? Are any of these messaging services available to run in-house? Yeah, that's a good one. I think this was up for discussion earlier. They have been releasing, I forgot the word, Azurite, I think it's called, for storage, which you can use for storage queues, but I don't think that's production ready though. But I think that's coming up actually, so you can use that. What do you think about using Event Grid as audit log storage across diverse services, working with the same data with a run correlation ID? I think if you want to have this as an audit, it's good because you can send out simple messages who have that. You shouldn't use it as a storage, but you should use it as a publisher of events. So Event Grid is awesome for making possibility to just spread these events that you want in any service you're using or any software you're building, and want to be able to listen to that at many places. Then Event Grid is really good, and you can definitely use that for that. How can we add the agnostic settings for Event Grid topic in ARM template? Well, you can. I don't have it here, but you can do that. I'm not sure if this export template or if you can look it out, but it shouldn't be an issue because it's the agnostic settings, which is, I think, the same for all resources. So check it out, or I might be able to put something up later on. I think that was all questions. At least I've accepted questions. Thank you.
cove.co.